For as long as humans have gazed at the heavens, one point of light has captured our imagination more than most. You've seen it. It hangs like a brilliant diamond in the twilight, just after sunset, just before sunrise. Ancient cultures saw it and wove it into their grandest stories. The Romans named it Venus for their goddess of love and beauty. To others, it was the morning star, the evening star. They saw it as a celestial guide, harbinger of dawn, harbinger of dusk, a beacon of serene beauty in the vast, dark emptiness of space. It's an easy mistake to make. Venus shines with a steady, silvery light, brighter than any star. It invites you to believe it is something gentle, something divine. But the universe is often stranger and far more interesting than our myths. As our tools of perception grew more powerful, we peeled back the layers of this celestial jewel. We sent our robotic emissaries across the void to get a closer look. The reality of Venus is a stark and fascinating contrast to its placid appearance. The story science tells is one of a world that may have started like our own, but took a dramatically different and terrifying path. So let's set aside the poetry for a moment and journey to the real Venus. This journey of discovery is a testament to human curiosity. We were not content to simply admire the bright light. We had to know what it was. What is this object that shares our cosmic neighborhood? Sun at the center, a small, hot rock called Mercury, Venus, the very next stop. It is the second planet from the Sun, our closest planetary neighbor. Venus can come closer to Earth than any other planet. That proximity helps explain its brightness. But there's another, more significant reason: the thick, mysterious blanket that forever hides its surface. That blanket is not made of water vapor like Earth's clouds, but something far more exotic and dangerous. In the grand family of our solar system, Venus is often called Earth's twin. If you just look at the basic stats, you can see why. Venus is only slightly smaller than Earth, about 95% of Earth's diameter. It has about 81% of Earth's mass. Its density and chemical composition are thought to be very similar to our own world. If you place them side by side, they'd look like two peas in a pod. The first clue something is very different is Venus's brightness. Venus is the most reflective planet in our solar system. That's because of its atmosphere. The planet is shrouded in a thick, unbroken layer of clouds that reflect sunlight. About 75% of sunlight that strikes Venus is bounced back into space. That reflection is why it shines so brightly in our sky. It isn't generating its own light. It's a spectacular mirror for the sun. These aren't fluffy white water vapor clouds like Earth's. Venus's clouds are made mostly of sulfuric acid droplets. It's the same kind of highly corrosive acid you might find in a car battery. That creates a permanent, planet-wide haze starting about 45 kilometers above the surface. From above, Venus looks like a smooth, pale yellow orb. From below, if you could survive, you'd be under a perpetual, oppressive overcast. No sunlight reaches the surface directly. Only a dim, eerie twilight filters through the toxic smog. Beneath those acid clouds, the twin analogy collapses. The Venusian atmosphere is crushingly thick and heavy. It's composed of about 96% carbon dioxide. That CO2 is a potent greenhouse gas. The sheer volume creates surface pressure more than 90 times Earth's. To feel that pressure on Earth, you'd have to dive nearly a kilometer into the ocean. It's enough to crush an ordinary submarine, let alone a human. This massive CO2 blanket is the key to Venus's most extreme feature, its heat. While Mercury is the closest planet to the Sun, it is not the hottest. That title belongs to Venus, and the reason is a textbook case of the greenhouse effect run amok. Sunlight filters through the clouds and warms the planet's surface rock. The surface then tries to radiate that heat back into space as infrared radiation. But the massive CO2 atmosphere traps this outgoing heat, preventing it from escaping. The heat has nowhere to go. It just builds up and up and up. Over billions of years, this process has turned Venus into a planetary oven. The result is a surface temperature that averages a staggering 465 degrees Celsius, or about 870 degrees Fahrenheit. This is hotter than the inside of a self-cleaning oven and hot enough to melt lead, melt tin, melt zinc. The temperature is remarkably uniform across the entire planet, from the equator to the poles, and from day to night. There is no relief from the blistering heat. Any water that might have once existed on the surface would have boiled away eons ago, and the molecules were subsequently broken apart by solar radiation and lost to space. Venus today is a bone-dry, scorching desert world on a planetary scale. This extreme environment poses an incredible challenge for exploration. The handful of robotic landers that have successfully reached the surface, primarily from the Soviet Venera program, were built like armored bank vaults. The images they sent back were historic, giving us our only ground-level views of this alien world. They revealed a landscape of flat, slab-like rocks and volcanic soil, all bathed in a dim, orange-filtered light. It is a truly alien and inhospitable place. On top of the heat and pressure, the weather on Venus is equally bizarre. While the winds at the surface are relatively sluggish, moving at just a few kilometers per hour, the upper atmosphere is a completely different story. The cloud tops, high above the surface, zip around the planet at incredible speeds, reaching up to 360 kilometers per hour. This phenomenon, known as superrotation, means the atmosphere circles the entire planet in just 4 Earth days. Why the atmosphere spins more than 60 times faster than the solid planet beneath it remains one of the great unsolved mysteries of planetary science. The strangeness of Venus extends all the way to its core. The planet has a truly bizarre rotation. Venus spins the other way, slow, ponderous, clockwise. This is called retrograde rotation. Why it spins backwards is debated. One theory, a massive collision early on knocked it over or reversed its spin. Another theory, complex tidal interactions with its thick atmosphere over billions of years. That slow backward spin makes a day longer than its year. Venus takes about 243 Earth days to rotate once. It takes about 225 Earth days to orbit the Sun, so a sunrise to sunrise day would last about 117 Earth days. You would see the sun rise in the west and set in the east, and unlike Earth, Venus has no moons to light its night sky. The surface is hidden by clouds, so we rely on radar. NASA's Magellan orbiter used radar to map the terrain beneath the clouds. Those maps revealed intense volcanism, vast plains of solidified lava, thousands of volcanoes, strange circular domes called corona, likely mantle upwellings. Venus doesn't have tectonic plates like Earth. It may release heat through massive, periodic volcanic resurfacing. This volcanism seems geologically recent. The low number of impact craters suggests resurfacing 300 to 600 million years ago. Whether volcanoes are active now is a hot research question. Recent data show sulfur dioxide fluctuations and localized hotspots, possible evidence of eruptions. Venus is active and reshaping itself from the inside out. The story of Venus is, in many ways, also a story about Earth. So, let's begin. Imagine you are an astronaut, looking at your solar system map. So, we have a portrait of a planet that is our twin in size, but our opposite in almost every other way. Scorching, high pressure, toxic. A day longer than its year, a spin that goes the wrong way, sky filled with acid clouds, ground covered in ancient and possibly recent lava flows. The story of how it got this way is perhaps the most important lesson Venus has to teach us. Evidence suggests that billions of years ago, Venus may have been much more like Earth. It might have had liquid water oceans, a climate that was potentially habitable, but its position, slightly closer to the Sun, was a critical vulnerability. As the young sun gradually grew brighter and hotter, Venus received more solar energy. Its oceans began to evaporate, putting vast amounts of water vapor, another powerful greenhouse gas, into the atmosphere. This created a feedback loop. More water vapor meant higher temperatures, which led to more evaporation, which meant even higher temperatures. This is the runaway greenhouse effect. Eventually, the oceans boiled away completely, transforming it into the inferno we see today. This history is a profound and sobering cautionary tale. It demonstrates that a planet's climate is a delicate balance and that a world very much like our own can be pushed into a completely uninhabitable state. By studying the atmospheric dynamics and climate history of Venus, we gain a crucial perspective on the forces that govern planetary climates, including our own. Understanding the runaway greenhouse effect on Venus helps us refine our models of Earth's climate and appreciate the potential long-term consequences of altering our own atmosphere.